Science is the field that humans pursue to understand, explore the world around them with the purpose of expanding the horizon of knowledge. To do that, science needs to experiment with new things, head towards distant frontiers, beyond everyday cognition to reach things that lie in the unimaginable. Hypotheses. That is also the main goal of science, to make hypotheses, explain the world around, then find ways to filter out the most accurate hypothesis. For that reason, proven hypotheses will also be pioneering things in science. When Einstein came up with the hypothesis about how the universe works, scientists took many years to calculate, experiment, and finally conclude that he was right. Since then, the field of astrophysics has had tremendous progress, helping humans develop further. However, that was not the only great advance in the history of astronomy. One day someone looked up at the sky, pointed to an endless void, and said, "What if there is a planet out there?" Since ancient times, when looking up at the sky, humans could easily see huge objects floating on it. They named them the Sun, the Moon, and further out of Venus, Mercury, Mars and Saturn. Those were the 6 objects in the sky that we could easily see. The rest we call the stars. The difference between planets and stars at that time was mainly in their motion. If they moved over time, they were planets, meaning wandering stars, and if they stood still in the sky, they were stars or bright stars. However, in the 17th century, when Galileo Galilei invented the telescope and began to look up at the sky, everything started to change. Humanity's view of celestial bodies gradually evolved. At first we only knew they were stars, bright things in the sky. Over time, we realized they were individuals in the universe, with cycles, the ability to spin, and most importantly, they were different from the sun. The things that used to be called stars were no longer bright. In other words, they were not distant candles. They were just huge spinning mirrors, and the light source was the sun. These discoveries gradually led to consequences and eventually led to the theory that unjustly condemned Galileo Galilei. The heliocentric theory helped humanity realize its position in the universe, that we are just lucky creatures on a lucky planet next to a lucky star, and that everything is too coincidental to be considered a coincidence of the universe. The question of the existence of extraterrestrial life made us increasingly curious about the world beyond this planet, and we continue to look up at the sky, hoping that if we look closely enough, we will see other people living on those planets. But while we haven't seen any aliens yet, we've learned a lot about the planets near us. The quest to explore and understand the universe has attracted the attention of many great minds, and from that we got Newton, born in the 17th century, not long after Galileo had his astronomical telescope. Newton was an ingenious man with a gifted brain. Thanks to his imagination and innate mathematical ability, Newton changed the whole world when he published his discoveries about the laws of motion. With Newton's laws, astronomers had additional basis to study and develop different hypotheses about the universe around them. Not only that, Newton's laws also provided the foundation for what we call gravity, something magical that pulls objects closer together. With Newton's formula for calculating the gravitational force between objects of mass, scientists could calculate the orbits, sizes and basic properties of the planets around Earth. It can be said that this was an important milestone in the development of astronomy. However, at that time, it was still the early days of astronomy. Humanity did not have the comprehensive view of the universe like today, partly because technology was not advanced enough to support more meticulous observations, and partly because we did not have any brains bigger than Newton's to fill the gaps in his research. A typical example, that Newton never really explained what gravity was. Despite his greatness, he was only the discoverer of gravity, not someone who could explain it. Although the formula he gave really helped astronomy move further, it still had limitations that researchers had to accept. One of those limitations was the scale of the gravity concept. In the 17th century, humanity was still vague about gravity. They still believed that gravity was a force, and were unsure whether it was unique to us or the same everywhere in the universe. Some scientists argued that gravity was only present in this small solar system neighborhood, that it was limited, and if you went too far everything would not follow Newton's laws anymore. For this reason, the discovery of new planets was quite strange at that time. Not because humanity had never considered the possibility of additional planets out there, but because they thought that beyond Saturn, everything would escape Newton's laws and start having different properties. And then in early March 1781, the German musician, Mr. William Herschel, invented a super cool telescope and looked up at the sky. At first this was just a new hobby he wanted to try, but then he saw something slightly odd in the Tauri 34 area. Not thinking he had discovered a new planet, he considered it a comet, and only dared to think it was a comet. But after many years of research and calculations, Mr. Williams' comet turned out to be a planet, Uranus. The discovery of a new planet stunned the astronomical community. Instead of thinking that there were no more planets out there, they now realized there was a whole ocean of planets left to discover. And while observing Uranus, they found something slightly strange about the planet. At this time, the gravitational influence of celestial bodies on each other was well understood and common. The Earth itself also sometimes enters a state of slight fluctuation when gravitationally influenced by the Sun and surrounding celestial bodies, so it was easy to understand Uranus' slight fluctuations as it orbited Saturn and Jupiter. But sometimes it fluctuated where there was nothing. The view that Newton's laws only existed within a certain scope was still maintained. The majority still believed that Newton's laws had certain limits, and beyond Jupiter's orbit, Newton's laws would gradually be disabled. But not everyone believed in this perspective. By the 19th century, as Uranus had nearly completed 1 year around the Sun, mathematician John Couch Adams and Urbain Le Verrier had studied its orbit, with suspicion that its fluctuations were due to the gravitational influence of another planet far out in the distant universe. It sounded simple, but this had never been done before. For a long time, humanity had used the motion and orbits of planets to calculate the gravitational attraction between them. But the problem John and Urbain posed was completely the opposite. They had to use gravitational influences to calculate the orbit and position of an imaginary planet. But they remained determined in Newton's laws and chewed over the numbers in their dreams. In 1845, they both got results, and Mr. Urbain Le Verrier was luckier than his classmate when he successfully sent his research to another astronomer, Johann Gottfried Galle. Mr. Johann was Urbain Le Verrier's friend, so he was not too hesitant to bring his research to his own telescope at the Berlin Observatory. And surprisingly, the dream planet of Mr. Urbain Le Verrier was almost exactly where he had put it in his research. This newly discovered planet then went down in astronomy history as the first planet discovered through mathematics and the law of gravity. From there, astronomers began to have additional tools to observe the sky. Previously they only had planets, brightness, cycles and orbits. Now they had mathematics and physical laws. It can be said that this was a great advance for astronomy, because it became the foundation for later scientists to continue studying the sky, calculating based on existing planets, deducing unseen planets, and using those dream planets to continue calculating other invisible planets. And when technology began to catch up with the power of the mind, humanity lifted the lenses and was blown away. Almost all calculations were accurate. What we once thought was just on paper was now right before our eyes. Seeing is believing. And this was truly a huge eye-opening moment for humanity. After being discovered, this planet was colloquially called the planet beyond Uranus, or the planet Le Verrier found. Of course, no one wanted a newly discovered planet to have such a colloquial name. After being recognized as the discoverer of the new planet, Le Verrier quickly proposed the name of the sea god for this planet. Naming planets after gods in Roman mythology was a common practice in astronomy history, so the name Neptune, god of the sea, gained consensus from most scientists at that time. As the last official planet, Neptune is unbelievably far from Earth. The distance between Earth and the Sun is about 152 million kilometers, which we call 1 astronomical unit, and the distance between Neptune and the Sun will be 30 times that distance, around 4.5 billion kilometers. Imagine the farthest distance you've ever traveled. Compare it to Earth and take it relative to Neptune's distance. At this distance, Neptune's orbit is so huge that it takes 165 Earth years to complete one revolution around the Sun, twice that of its closest sister Uranus at 84 years. Speaking of Uranus, Neptune also has a lot in common with this planet. First, the masses of the two planets are relatively uniform. Neptune is about 17 times larger than Earth and has an equatorial radius equivalent to 24,764 kilometers, 4 times that of Earth. Additionally, the properties of Uranus and Neptune are quite similar, both composed of water enveloping a super-dense solid core. The planet's core is hypothesized to be made of solid water, silicate rock, and many other impurities, containing more than 40% of the planet's total mass. With Neptune's size, the core of the planet will be enormously 1.5 times the size of Earth. The planet's outer layer is mainly water, ammonia and frozen methane. These numbers make us think that Neptune is a slow, gentle planet, an ice cube floating lazily across the sky. However, the reality is the opposite of imagination. Neptune is a planet with a dizzying rotational speed. Although 1 year on this planet lasts over 160 Earth years, 1 day on it is not even the waking time of a person. A day on Neptune is only 16 hours on Earth. At this spinning speed, the distant planet has winds reaching speeds of up to 1,900 kilometers per hour. These winds are 5 times stronger than the strongest storms on Earth and have the deadly characteristic of arriving before you hear them coming. Because the wind speed is so fast, it travels faster than sound itself, causing anyone standing on this planet to be swept away before having a chance to hear it coming. But that is for the hypothetical case that someone is actually standing on this planet. Classified in the same category as gas planets, Neptune has no surface and is just a huge water tank. There would be nothing that could stand on this planet. However, this is unfortunate, because if we had the ability to get there, we could verify an interesting hypothesis about Neptune. According to the hypothesis, Neptune may have strange rains, diamond rains, That's right, we did send a ship to Neptune to study it. But in the history of astronomy, we have only done that exactly once, with Voyager 2. In August 1977, Voyager 2, the twin of Voyager 1, was launched into space to explore distant planets. In 1981, the spacecraft passed Saturn and was catapulted farther by the giant planet towards the next planet, Uranus. There it sent back invaluable information to humanity about the quirky planets of the solar system. After completing that wonderful expedition, Voyager 2's next target was the 8th planet, Neptune. On August 25, 1989, Voyager 2 approached the farthest planet in the solar system. This journey was calibrated for Voyager 2 to fly straight through the Neptune system and Triton, its large moon. Thanks to this route, Voyager 2 could pass through the icy planet and head towards the infinite expanse of the vast universe, becoming one of the first spacecraft to escape the solar system. It can be seen that Voyager 2's cruise past Neptune seems brief, but the information it brought back is truly invaluable to us. Neptune was the first planet hypothesized mathematically, and for many years, we could only see it as a tiny white speck in the sky. After telescopes were developed, we saw the white speck more easily, but it was still just a white speck. Voyager 2's journey was the first time we got to witness firsthand the grandeur of the giant ice planet. The most prominent thing about this ice planet was a huge black spot on its atmosphere. This black spot was a raging storm churning on the planet's surface. The size of the storm can rival Earth. Not only that, this storm also circled the planet at breakneck speed. Additionally, this storm had a little sister in the southern hemisphere of the planet. However, These were not eternal storms like those of Jupiter and Saturn. After the Hubble telescope was put into orbit and began shining on the planet, we no longer got to see those storms. Instead, there were new storms, new cloud patterns, proving that Neptune's weather is truly dynamic. However, the climate of this planet is still strange. We know storms only occur when there is convection, and with gas planets that have atmospheres thicker than Earth, having storms is normal. However, an icy cold planet like Uranus would hard. When Voyager 2 looked closer through its infrared lens, a new discovery was identified. It turns out this ice planet is not as cold as we thought. Although the furthest planet in the solar system, Neptune is not the coldest planet. That crown belongs to its sister Uranus. But why is this so? Shouldn't the furthest one, getting the least sunlight, be the coldest? What makes the difference between these twin planets? The answer probably does not lie with Neptune, but with Uranus. According to astronomers, one way to explain Uranus' sideways axis is that, in the distant past, a planet the size of Earth collided with Uranus, causing the ice planet to tilt in such a remarkably way. That collision not only knocked Uranus on its side, but also caused the planet to lose most of its ability to self-generate heat. So, without that collision, Uranus might have been like Neptune, an ice cube spinning with stable self-heating capabilities. However, that is still just a hypothesis. We do not have a time machine to go back to the past and confirm this, or at least not until Voyager 2 and its other siblings send back information from the vast universe, letting us know that out there are also planets similar to Uranus and Neptune, so that we have enough information about collisions outside the universe from which to infer the official reason. So is that it? Voyager 2 flew by and only brought back images of just storms and a bit of trivial information, right? In fact, we had many other fascinating discoveries, but most were information for astronomers to create more effective future missions. But that does not mean we have nothing more to say about this distant fuzzy planet. Surprisingly, Neptune was not much different from the three giant gas planets before it. In the past, when looking up at the sky with its tiny white speck, it was hard to say what was special about this planet. But when Voyager 2 pointed its lens at it, we had to explain, because it turned out that tiny bright speck had a whole splendid ring system no less impressive than Uranus. Neptune has between 5 to 6 rings around it. These are soft, thin rings with bright arcs created by the planet's tiny moons. These rings have fantastically poetic names like Gale, Levaria, Arago and Adams, as you can see. These are the names of people who contributed to discovering this planet, from mathematicians to astronomers at the Berlin Observatory. Not only that, the bright arcs of the rings also have names like Liberté, Eagle-Eye, Fraternity and Courage, meaning liberty, equality, fraternity and courage. Poetry is like that. But these rings are almost invisible in telescopes. The main reason is because they are too thin to reflect sunlight. And at such a distant position, they would be drowned in the black curtain of the universe. But still, the rings are there, still a wondrous part of creation that humanity got to witness in its brief history. And that was the story of Neptune, the last planet in the solar system. And that was the story of Neptune, the last planet in the solar system. I have summarized the story of the giant gas planets in Earth's little family, while also closing the chapter on Neptune here. How do you feel about these planets? And how do you feel about the outer space story of this section? Please answer our questions by leaving your thoughts on the whole season in the comments below. Also, if you like content like this, don't forget, the universe is still vast and huge. Stories about it will last forever, and we will continue to tell about planets, stars in the future.